So this video will demonstrate how to white wire a board. The term white wire comes from the old Teflon coated wire, bus wire that used to be used. It's not necessarily going to be white. What we see is identifying that there should have been a connection between the trace that we're about to cut and the capacitor to the left. Video in a screen is sure better than 40 hours of letting the software convert it. 20 to chemistry is probably the best idea you've ever had. Because God knows computing sucks. One of the challenges with doing micro soldering repairs like this is watching the screen with your eyes and controlling the movement with your fingers. Takes a little bit of hand-eye coordination. What he's doing right now is working the knife blade through the copper material to create a bridge or to create a break in that wire. We're relying on the fact that there's fiberglass underneath the copper, and that if you just wear through that thin layer of copper, we'll get down to the kind of whitish fiberglass. We want to have a sufficiently large amount of break so that when we connect the wire with solder, that the solder can't kind of liquefy and flow over a small cut. Sometimes we'll want the exact opposite. We'll notice a small cut in the board and we can use solder to cross over that break. But in this case we want to have enough insulation between the two so that there's no random acts of conductivity. He's now going to use the probes and actually test for conductivity. These are actually the micro probes, so if you're used to seeing the probes in a regular multimeter, these are actually the micro ones. And so a sanity test is to make sure your meter is set up right by checking for continuity on the pin itself and then checking across the gap and there's no connection.
Alright, so now we're going to actually prep our wire for doing our wiring job. I'm going to use the 28 gauge. We have a couple different sizes. We have a 30 gauge, which is the original white, and we have a 26 gauge, which is red. The larger number, the smaller the wire. Now, the easiest way to do this is if you look at the end, it will tell you exactly what gauge that's designed to cut. I currently have it set for 28 gauge. So while it's on the spool, this slides back and forth to determine just how much wire you're going to strip off. Usually you really don't need to strip off a lot, so I usually leave it pretty close. Voila, nice clean strip. Now you figure out about how much wire you're really going to need for the job. And in this case, you always go a little bit longer so you have room to work with. Just kind of snip them off. Now here is where it gets a little trickier, because now stripping off that same bit of wire, you don't have a lot to grab onto. So the easiest solution is you glue them up, grab them with a pair of pliers, and pull them out. Now you have a nice small length of wire, and you don't want to squeeze too tight with your pliers because you don't want to screw up and accidentally strip off that shielding. And if nothing else, nice thing about having this really good scope is you can confirm that I didn't actually break any of the insulation, so I'm not going to accidentally introduce any shorts. Now you would use potentially the pliers or the tweezers to mold it to the direction you want it to go. So in this case, I want it to connect. This part is going to connect right here, and in this case I have quite a bit of extra wire. So I'm going to snip off just a little bit of that. You got to remember, more exposed wire you have, the greater your chances are for shorts. So we are going to want him to basically be right there. We might want to take this razor blade and strip back a little more of the green to give us a bigger space to work with. In this case, what we're going to do is we're going to solder that little piece. We're going to get out our flux pen, add just a dab of flux to what we want, and just a little bit on the tip there. Now, the easiest way to do this is actually get a little bit of solder on the tip of the soldering iron. So you just have a little ball kind of hanging out on there. Works a lot better when your tip's not on his way out. That's a lot more than I normally want. There you go. And now, before you go putting too much on, your next test will be to make sure that you haven't introduced a short. So we don't want it connected there, and it's not. We do want it connected there. Okay, now that we know the one side is good, we said we wanted this to be connected to the back end of that cap. So bring the part over here a little bit. See where we want it. We know we're going to want them right about there. We have a little bit of extra wire on the end, so we can go and snip him off because we don't need that much. That leaves us with just about the right amount. And now we get out our flux pen and dab him up to prep him for what we're going to do. And in this case, the easiest way to do it, let me turn him this way because I don't want a little bit of solder. And if you notice, I'm holding them in place until the solder kind of goes dull, which means it's hardened. And now we should have a nice white wire solder bridge. So now, last step is to test. There to there. Okay.